My name is Brian Kliszczewicz, and I'm an Associate Professor of Exercise Science in the Wellstar College of Health and Human Services. I originally became interested in exercise science when I was an undergraduate student playing lacrosse at Mercyhurst University, and I enrolled in the sports medicine program with a concentration in health fitness promotion. And through this experience, I was exposed to a unique blend of exercise prescription, physical therapy, and injury management. Then I was fortunate enough to get accepted into the University of Florida's Master's Program of Health and Human Performance. It was there that I became exposed to the world of research. I was trained in benchtop techniques and observed and trained in several research labs including skeletal muscle atrophy, oxidative stress, and nitric oxide. The lab training and personal connections that I made eventually led me to my doctoral program at Auburn University. At Auburn University, I studied under Dr. John Quindry in the Cardiac Protection Lab, where I further developed my benchtop research skills. Additionally, I was working with another faculty member at Auburn University at Montgomery, with Dr. Michael Esco, where I was exposed to cardiac autonomic stress through the measure of heart rate variability, or HRV. Together, these two metrics provided me with a way to examine physiological stress via biomarkers and non-invasive measure of autonomic nervous system regulation. During my last year at Auburn, I was heavily involved in CrossFit training. And interestingly, many people in the exercise science community were apprehensive of this modality, despite the level of participant interest and retention. Was this modality as dangerous as some may have suspected? Well, this led to my dissertation project examining a commonly performed bout of CrossFit and comparing these markers of stress to that of an intensity-matched running bout. Briefly, when evaluating biomarkers of oxidative stress, we found no differences. When looking at cardiac autonomic stress, we see an increased amount of acute stress experience in the CrossFit group, but both return to baseline at the same time, suggesting limited difference in the experienced stress. With the popularity of the CrossFit modality in the general population, I began to shift my focus towards the application of this exercise to sedentary and at-risk populations. And chief among these populations are those with type 2 diabetes. This is a progressive disease that is a critical public health concern in industrialized nations. More than 34 million adults are living with diabetes in the United States. And the most pragmatic approach to prevent or slow the progression of type 2 diabetes is through physical activity or exercise interventions. However, before I approach this problem, I wanted to gain a better understanding of the dose response and the accrued stress of various bouts. And so we examined two different CrossFit-style workouts, one 15-minute circuit and the other a sub-5-minute bout, to see if there were any differences in adaptive markers or potential differences in physiological stress. What we saw when looking at the results of cardiac autonomic strain or autonomic nervous system recovery, we see what looks to be superimposed figures suggesting that there was virtually no difference in the depression or the rate of recovery in autonomic nervous system markers or biomarkers. When looking at various markers of growth and inflammation, we saw a similar response in that no real significant differences were observed outside of growth hormone, which is more of a metabolic stress indicator. Lastly, we see that blood glucose regulations react similarly. And so what we learned from this is that a sub-5-minute bout of exercise is stressful enough to elicit similar acute physiological responses to that of the longer 15-minute bout, and expressing no differences in physiological stress. How can we use this information? Seeing little difference in physiological stress and similar acute adaptive responses in healthy recreational men with the sub-5-minute bout, we set out to create a very low time commitment, 12-week bodyweight circuit training program for people with type 2 diabetes. This program started with an initial 5-minute bout 3 days a week and progressed to 8-minute bouts 4 days a week. The bout consisted of 10 modified bodyweight squats, 5 modified push-ups, 5 modified pull-ups, and 10 crunches. The study was short-lived because we saw a fundamental flaw. After 3 participants had completed the exercise program, we saw positive changes in strength, aerobic capacity, and fasting blood glucose. However, HbA1c, a diagnostic marker of diabetes, did not change. The program was not long enough of a duration to elicit a response. So we revamped the program and changed the intervention to be 16 weeks and had the sessions performed at home. Prior to funding running out, we were able to get 8 individuals into the study, with 2 dropping out for personal reasons and 1 with too high of insulin levels. The 5 who completed the program demonstrated very promising changes. These findings served as the pilot feasibility data for a grant proposal submitted to the National Institute of Health, which hopefully will be funded. Between 2012 and 2017, the financial cost of this disease increased by 26%, with an average financial burden of roughly $9,600 per patient each year. As of 2017, the overall direct and indirect cost of this disease was estimated to be $327 billion in the United States. Finding pragmatic, cost-effective countermeasures to slow the progression and treat diabetes is not enough. Providing additional programs that are both time-efficient and appealing is urgently needed. We believe our intervention will be a successful tool in fighting the progression of type 2 diabetes. Our next step is to examine recently diagnosed patients with type 2 diabetes and apply our intervention in order to slow the progression, if not reverse it. If this becomes successful, we can then move to examine those with more advanced forms of type 2 diabetes, and from there the world opens up to us. And one final note, I would like to take a moment to recognize the student researchers who have made my research possible over the years here at KSU. I've been fortunate enough to work with some incredible students. Thank you all.